Hello students, in this video, in continuation to our previous 3 videos, we are going to work out the problems associated with Wagner-Merwin rearrangement and Wolff rearrangement. Okay, so Wagner-Merwin rearrangement, as I said in the previous, in the first video, Wagner-Merwin has some similarities with pinnacle-pinnacle-owned and semi-pinnacle rearrangements. These 3 can be coupled in one folder. This is what I said in the first video. See, for example, R H plus. This is pinnacle-pinnacle-owned. I already said pinnacle. This is pinnacle-pinnacle-owned rearrangement. And R OH. Next one is a leaving group. Okay. This is semi-pinnacle. This also I already told. And third one is Wagner-Merwin, as I said. The first one 2 hydroxyl group. Here 1 hydroxyl, the other one is a leaving group. Third one is Wagner-Merwin, as I said. Only 1 OH. Next one is, this is Wagner-Merwin rearrangement. So you will have only 1 hydroxyl group. R is a leaving group. Okay, leaving group. Okay, either you will have only 1 hydroxyl group or a leaving group. Okay, there is a similarity with the starting materials. First one 2 hydroxyl group. Next one is only 1 hydroxyl and a leaving group. And Wagner-Merwin, no leaving, just only 1 hydroxyl group, or else a leaving group, whatever. Okay, so this way the Wagner-Merwin resembles the first 2 rearrangements. Okay, now let us see the Wagner-Merwin reaction. See, for example, let us take neopentyl alcohol. If I treat with H plus, what will I get? The mechanism is, if I treat with H plus, I will be getting OH2 plus. I will get a cation, isn't it? So this cation is a primary cation, unstable one. As a result, this methyl group migrates, 1-2 migration of methyl group. So I will get earlier it was a primary carbocation, here it was primary cation, here I get a tertiary cation. So this is stable now. Next step is, if I have a nucleophile, the nucleophile will attack. Nucleophile will react with the carbocation. In case I don't have a nucleophile, then what will happen means, here there is a proton, so this proton will come here, so I will get a olefin. So it is merely decided by the stability of the rearrangement. You get a cation and to stabilize a cation, the adjacent group migrates. As a result, you get a stable carbocation. If you have a nucleophile reacts with the cation. If you don't have the nucleophile, you will get olefin. This is the Wagner-Merwin rearrangement. I compared this one with other pinnacle and semi-pinnacle, means there is only one hydroxyl group or a leaving group. That is all. It is similar. It resembles the previous two. Okay. So this is all about Wagner-Merwin rearrangement. In case there is another type, the another type is this one. Okay. Apart from that, there is one more type of Wagner-Merwin rearrangement. It is this one. Instead of neopentyl alcohol, I have a olefin. Okay, I have a olefin. Now let me treat with HCl. What is the product? It is the first step is H plus reacts, the proton reacts. It reacts according to the Markovnikov rule. So you get a carbocation, isn't it? Next step is the 1,2 migration of methyl. Methyl group migrates. Methyl group migrates. You will get a carbocation here. Okay. Now the chlorine, because H plus Cl minus, the now chlorine Cl minus, the nucleophile reacts and you will be getting and chlorine. Okay. Here you had a secondary carbocation, but now you had, after migration, you had tertiary carbocation, and that stable carbocation the nucleophile attacks. Okay, you get the product. Okay, this is the product. This is another type of Wagner-Merwin rearrangement. First type is hydroxyl group or leaving group goes out. You get a cation. The cation is stabilized by rearrangement. Then nucleophile attacks are the olefin formation. Next one is, instead of having leaving group or hydroxyl group, you have a olefin. The olefin is treated with acid. Okay, so you get a cation. From that you get a stable cation by rearrangement, then nucleophilic attack. This is another type of Wagner-Merwin rearrangement. Okay, a question was asked in 2012. The major product obtained in the following reaction is 2012 question, JAM. Okay. Here HCl, olefin. Okay. This compound is, I think, camphene. Okay. What is the product? Look at the camphene here. The first step is reaction with proton. The product is cation, isn't it? This is a tertiary carbocation, and this one is attacked by the nucleophile Cl minus. So okay, this product is here. Yes or no? This product is here. I think this one A is the product. Okay, but actually I was telling you about Wagner-Merwin rearrangement. Where is the rearrangement here? We never encountered any rearrangement. Just we generated a cation and nucleophilic substitution. You got the product. Nothing about the rearrangement. Okay. So certainly this is not the product. Moreover, this sort of compound, this reaction is very much characteristic of the non-classical carbocation. Okay, so let us see. Actually what is happening means this one goes out. Okay, nucleophile attacks. With that the reaction doesn't stop. The chlorine goes out and there are 2 electrons in this bond, This bond comes here. This electron comes here. As a result, we get a product like this. We get a product like this. Okay. In fact, this is actually what is happening. This is equal to okay. In between there is positive charge inside. Okay. So this is called non-classical carbocation. Actually the 2 electrons stabilize this carbocation generated by the departure of chlorine. Okay, so overall 2 electrons but 3 carbons, 1, 2, 3. Okay, so this is called 2 electron 3 center bond. So this is an example of non-classical carbocation. Probably we'll upload a separate video on non-classical carbocation later. So you remember that this is a non-classical carbocation. So now the nucleophile, chlorine. Okay, chlorine. The chlorine can attack here or chlorine can attack here. Okay, and this there is one methyl, it has to be. Okay, if the chlorine attacks at this place, at this carbon, I will get this one. Exactly the same thing I will be getting. If the chlorine attacks here at this place, I will be getting this one only. If the attack takes place here, if the attack takes place here, then I will be getting the chlorine here. Okay. Now I tell you, catch hold of this carbon and this carbon, and this carbon. Catch hold of these 2 at one hand, maybe right hand. Catch hold of these 2 at left hand. Okay, and spread it upside down as you spread a book. For example, if a textbook is like this is a textbook, open textbook. You tilt it upside down. Now you have tilted upside down. In the same way, you tilt it upside down. If you tilt this one, you will be getting okay, if you tilt this one as you tilted this book, you will get this compound. Where is it? Where is this compound? Yes, option C. C is the answer. Okay, so this is not only Wagner-Meerwin, Apart from that, it involves the non-classical carbocation. Okay, the campene involves a non-classical carbocation, which is a very important reaction. Okay, very typical of non-classical carbocation. You have to remember that and practice it. Okay, and next rearrangement that we are going to study is Wolff rearrangement. Wolff rearrangement. Wolff rearrangement. The Wolff rearrangement is this. Take a diazoketone. You would decompose the diazoketone by a light or a metal. Okay, you will get a carbene. Okay, you will get a carbene hydrogen. You will get a carbene. Next step is okay, this one comes here and this migrates. Okay, the R group migrates to the carbene and the 2 electrons delocalize here. See, for example, if you assume that this is a carbene, if you assume R this is hydrogen, there is olefin, there is double bond, and there are 2 electrons. In addition to that, you have a vacant p orbital, let me say, vacant p orbital. Okay, so actually singlet carbene is sp2 hybridized. So this is a vacant p orbital, it is empty, and this one is non-bonding sp2 orbitals. So what is happening means there are 2 electrons here, so these 2 electrons come here, come to this vacant p orbital. At the same time, the 2 electrons, non-bonding electrons, delocalize here. Okay, so that is what happening actually. So this is equal to C double bond O CH R. Okay, so this is a ketene. So this ketene can be converted into, by treating with water, the ketene can be converted into, okay, R COOH. RCOOH. What is happening right from here? R CH2 COOH. So if we compare, okay, this is, and if the same ketene is treated with methanol, I will get R COOME. Again it is treated with amine, NH2, let me say, R prime NH2. So R CONH R prime. So I get acid, I get ester, I get amide. Okay, everything is from this ketene. Ketene is an unstable species. Okay, so This is Wolff rearrangement. The real application of Wolff rearrangement is the ketene, the conversion of ketene into various products. Okay. And how can I get this one? How can I get this diazo compound? Means if I take, for example, let me take an acid. I can convert this acid into acid halide and treating this with diazomethane. Okay. So now you look at this acid, starting material of this acid and final acid. Compare these two. What is happening? I started from this acid, I got a diazoketone. Okay. Then Wolff rearrangement, I got ketene. And treating that ketene with water, I got this another acid. So if this is acid, this acid to this acid finally, I come through Wolff rearrangement. Starting from this acid, coming to this acid through Wolff rearrangement. Compare these two acids. What is the difference? Here a CH2 is added, isn't it? Okay. Chain length increases. This is called homologation. Okay, homologation. So this entire sequence is called, okay, starting from here to this acid to this acid. Okay, all the Wolff rearrangement, okay, diazoketone, Wolff rearrangement, ketene, hydrolysis, everything, including everything, starting from this acid to this acid. Okay, that process is called and ester homologation. And ester homologation. Okay, this is all about Wolff rearrangement. Okay, let us see one example. This is the question asked in 2013. Look at this. Complete the following reaction sequence. Okay, complete the following reaction sequence. The first step is, okay, this halogen is treated with a base. What is the product? The halogen is treated with the base. So here is a proton and here is another proton. Okay, when you treat with a base, the role of the base is to remove the proton. So you will get a carbene. Okay, carbene. Okay, here in the bracket itself it is mentioned that you get a carbene. So this is product K. And next step is carbene gives L, because carbene is an intermediate unstable species. So it will do some other reaction. The other reaction, two reactions I expect. First reaction is a rearrangement. Okay, this entire group rearranges. As a result, this olefin comes down, as we saw just now in the Wolff rearrangement. Okay, so the product is double bond methyl phenyl hydrogen. This is the compound I anticipate. What is the next one I anticipate is, let me rewrite the same compound again. Okay, this is equal to okay. Okay, this is methyl, this is another methyl, and here there is a hydrogen. Okay. So there can be CH insertion. Okay. Carbene can undergo cycloaddition, it can undergo rearrangement, it can undergo CH insertion. So this one is rearrangement. Here I anticipate CH insertion. CH insertion means in between this carbon and hydrogen, this carbene inserts. That means I will get the product this way. The product is supposed to be, if it inserts means it should come here. In between carbon and hydrogen, this carbon should come. So the product is here the methyl, here this methyl, and insertion. Okay, the hydrogen is here, and maybe this hydrogen is also here. Okay, you understand? So in between this carbon and hydrogen, this carbon inserted. Okay, this carbon inserted. Okay, as a result, I get cyclopropane. Okay, but which one is right means the next step is what? Okay, if I can assume that this is L and this is also L, but the next step is, if I look at the next step is treatment with MCPBA. MCPBA is an oxidizing agent, epoxidation, Baeyer-Willig rearrangement, whatever. But if you look at these two compounds, MCPBA will not react with this. There is more chance to react with this olefin. If it reacts with the olefin, what will be the product? Product is an epoxide. Okay, product is epoxide. Okay, product is an epoxide. So certainly this is L, and this cannot be the L. Okay, because next step is MCPBA reaction. MCPBA reacts with this one, not with this. So L is the reasonably accepted one. Okay, next step is what you got? M. This is M. Okay, and what is next step? HCl. If I go for HCl, hydrogen can attack this oxygen. Okay, hydrogen can attack this epoxide oxygen. If it attacks, you get a positive charge on the oxygen. So two side bond breakage can take place or here. So if this bond breaks, the chlorine can attack Cl minus. The Cl minus is the nucleophile. It can attack here or here. Okay. So if I write both the product, if the attack takes place here, if the attack OH chlorine attacks here, okay, OH, and if the attack is here, the same Cl minus OH. Okay, and here OH. Okay, so these two products, so that's what they mentioned. There are two products obtained. One is N and O. So if I assume that this is N and this is O. Okay, so this is all about the entire sequence. Let me narrate once again. You generate a carbene. Carbene undergoes rearrangement and not CH insertion. If it rearranges, you get a olefin. Okay, that is product L. On treatment with MCPBA, you get epoxide. Epoxide on treatment with HCl, you get ring opening. Epoxide ring opening. When the epoxide opens, two sides are possible. One may be minor, one may be major. That is different case. But you get two products. Okay. So the chlorine can attack here and chlorine can attack here. Okay. Nucleophile attack. So this side attack gives this product M and this side attack gives product O. So N and O. Okay. Two products you are obtaining. And this is the entire sequence. The main thing involves here is the carbene and then the rearrangement. Okay. I hope you understand all these things. We have almost covered all the rearrangement reactions, especially in the reactions which is pivotal for the JAM exam based on the previous year's questions. Okay. So if you have any queries, any comments, please write on the comment box. Okay. And we will meet in the next video with some other topic. Okay. Wish you all the best. Thank you very much.